everyone, and welcome to another episode of the show about science. This is your host, Nate, and today we are going to be talking to Paul Davies about whether or not you can travel forward or backward in time. It's going to be an exciting episode, so let's time travel forward to the beginning of today's interview. Hi, welcome to the show.
It's a pleasure to be here. Thank you for inviting me.
You're welcome, Paul. I'm super excited to have you on the show today. So, you're a professor at Arizona State University in Phoenix, where you direct the Beyond Center for Fundamental Concepts in Science. So, can you tell our listeners a little bit about yourself and what you do at the Beyond Center?
Right. So, we work on all of the things that people are really interested in, like the origin of the universe and the origin of life and time travel and space travel and consciousness and quantum physics and all that fun stuff. But by background, I'm a theoretical physicist. That's how I started out. And I grew up in London, in England, and that's where I went to school and university. And eventually I became interested in a lot of other things like life beyond Earth and the subject of time travel.
Okay, so let's start there. How did you become interested in physics and time travel?
Well, I suppose when I was your age, I began reading science fiction. So there was a very famous British science fiction writer called H.G. Wells, and he wrote the first time travel book ever called The Time Machine in, I think, 1895, around about that time. And I read that as a youngster, and it's a very thrilling idea because I think we're all rather fascinated by the nature of time. Again, when I was your age, I used to think a lot about these things, and I used to wonder, does space come to an end, or will it go on forever? And does time come to an end, and has there always been time? And then I used to think to myself, well, why am I living now rather than some other time? It was all a great puzzle to me. So I love to read time travel books. And then now let me tell you a funny story. I wrote a book about time. It was called The Physics of Time Asymmetry. It's my very first book. And I wrote this book in the 1970s, to say I'm that old. And it was a very influential book. And another astrophysicist, Gregory Benford, came to see me back in the mid-1970s, and he was writing a book called Timescape. And he wanted to ask about aspects of time, and we talked about it. And then a few years later, I saw this book, and I bought it, and I was astonished to find that although it's a book of fiction, it's a novel, I'm in there as a character. And so I thought that was a wonderful thing to be a character in a science fiction novel. And I've since got to know Greg Benford very well. He's written many, many science fiction books, and I see him quite often. So that was my introduction to not only reading time travel science fiction, but being in time travel science fiction.
So, Paul, is forward time travel just the stuff of science fiction? Or to rephrase that, is time travel into the future even possible?
Forward time travel is certainly possible because we've done it. This was predicted first by Albert Einstein, probably the most famous physicist who ever lived, in the year 1905. And to travel forward in time is actually really easy. You just have to move very fast. I'll give you an example. If I get on a plane in Phoenix and fly to London and back again, and you stay behind, then my time and your time gets slightly out of kilter. There's a mismatch, not very much, only a few nanoseconds, billionths of a second, but it's actually measurable. Clocks these days are so incredibly accurate. You can measure the time warp or time shift just from aircraft travel.
Wow.
Now, if you travel faster, this shift gets bigger. So an astronaut in orbit might come back, a few microseconds younger than the astronaut would have been by staying on the ground. To get really, really big time shifts, you have to travel close to the speed of light. That's 300,000 kilometers a second. So it's enormous speed. But if you could do that, in principle, you could go on a trip, say, to some nearby star and come back. And for you, the time of the journey might be, say, 2 years. But when you got back, you'd find that 20 years had elapsed back here on Earth.
Wow.
So in effect, you would have leapt 18 years into Earth's future. And so travel into the future like that is certainly possible. To do it in dramatic amounts, like I just said, getting close to the speed of light, that's not feasible for human beings, but you can do it with subatomic particles. These are fragments of atoms that can fly around at enormous speeds in giant accelerator machines. And you can measure their internal time, their internal clock, and compare it with the clock in the lab. And the mismatch is like thousands of times. So we know this is a reality, travel into the future. But you can't use high speed like that to go back in time. It's a one-way journey only.
So do you know how you could possibly go back in time, or is there a way to?
Well, there are a lot of speculative ideas, and this man, Albert Einstein, who came up with all these facts about time and space and gravitation, called the theory of relativity. And it's something that I have been working on all of my career. And there are two ways in which the theory of relativity tells you that you can have funny things happening to time. One I've just mentioned, which is speed, but the other is gravitation. So gravity slows time. Time, if you have a clock down here on the ground, it ticks slightly slower than a clock up in space. And again, you can do this experiment. And so it's, once again, a tiny, tiny effect, billionths of a second. But if you have a really big gravitational field, the slowing of time can become enormous. So, for example, on the surface of a neutron star, which is like a star made entirely of neutrons, which would have the mass of something like the sun, but squashed into the size of a city. And these things certainly exist, these neutron stars. The gravity is so intense, the atoms collapse under their own weight. They're crushed into neutrons. So it's a ball of neutrons just a few kilometers across. And if you put a clock on the surface of a neutron star, we can't do that, but if you were to do it, then that clock would tick about 30% slower than a clock on Earth. And now, if you want a really, really big time warp, the surface of a black hole is like an infinite time warp. If you fall into a black hole, when you cross over the horizon into the hole itself, the whole of eternity will have passed in the universe outside. And so it's like an infinite time warp. So to go back in time, what you need is something like a black hole. But a black hole is a one-way journey to nowhere. You fall into it, you can't come out again. What you want is something like a black hole with an exit as well as an entrance. And we have a word for that. It's called a wormhole.
Ooh.
A wormhole in space. It would be like a stargate or a shortcut between two distant points. And it's easy to talk about it and you can write equations, but we don't know that wormholes actually exist. If they did, it would be possible to travel through a wormhole and come out, say, on the other side of the galaxy a few minutes later. And then if you were to travel back through ordinary space very close to the speed of light, then you can show using mathematics that you would get back before you fell in. And so this would be a form of backward time travel. So if you believe all this, and it's based on this theory of relativity, then backward time travel seems to not be impossible. But of course, just because the theory of relativity says it's not impossible doesn't mean that it is possible, because there are many other branches of physics that might prevent you doing it. So the answer to your question is maybe travel into the past is possible, but we've certainly never done it. And it may be one of these things that in principle could be done, but in practice it can't. Just because the theory of relativity says it's not possible doesn't mean that it is possible, because there are many other branches of physics that might prevent you doing it.
Do you think that we'll ever be able to travel at the speed of light so we can do forward time warps like years into the future?
In science fiction, this seems to happen all the time. People talk about spacecraft traveling at close to the speed of light. It's not a problem of physics. We know that objects do travel very close to the speed of light. I've already mentioned subatomic particles. You can whirl those around at like 99.99999% of the speed of light. So this is done on a routine basis. And cosmic rays, which are coming across the galaxy, these are protons, subatomic particles traveling extremely close to the speed of light. So we know there's no problem of physics. It's really a problem of engineering and money. You certainly wouldn't want to build a conventional rocket ship to try and do it because the amount of fuel costs would be stupendous. And people have looked at rather fanciful alternatives, like if you go near to a spinning black hole, there is a way of trying to tap into the rotational energy of the black hole to propel something at very high speed. Another method is to use the pressure of light itself, exerts a small pressure. And if you do that for long enough, you could get to very high speeds. But it's an enormous challenge, and it would be a wonderful thing to do it. When you think that the nearest star is 4 1/3 light years away, which means even at the speed of light, it would take 4 1/3 years to get there, you see that the universe is very, very big. And so when we think of TV series like Star Trek or any of these science fiction stories about people traveling across the galaxy to distant worlds, none of this could really happen with our present understanding of physics, unless we can find some way of getting very close indeed to the speed of light.
All right, so let's say that we do find some way to go at the speed of light. Do you think that a human would be able to survive that journey?
There's all sorts of problems, actually, of going close to the speed of light. And one of these is that space is not completely empty. There are little specks of dust. Sometimes these are called meteoroids. And if you hit even a speck of dust at close to the speed of light, that's like a nuclear explosion. So you would have to have some way of burning them up in advance or shielding them, something of that sort. And then there's the problem of the acceleration of getting up to the speed of light. Human beings can withstand only a few Gs, that is, the sort of force that we feel when we just rest on the ground, pulling us down. If you had, say, 2G, you might get away with that for a few hours, but it would start to become problematic. And so if you just accelerate at 1G, to get to the speed of light is going to take a very long time. And then you've got to decelerate at the other end. And so these are real problems. And furthermore, there is, of course, the problem about if you do this, you go off to some distant planet, you maybe explore, bring back a few samples or something. And when you come back, you might find that you come back decades into the future and all your friends and relatives are all much older and you've missed out. So that there would be, I'm sure, psychological problems of people that would come back and find that the world they knew has gone. So all these problems, physical, engineering, and psychological, mean that this may never happen. It may be a distant prospect.
So what can we do with this information?
That's actually a very good question, because a lot of our listeners might think, well, is this guy, Paul Davies, really being paid a salary to think about this crazy stuff? And how could this possibly be of any use to anybody? And there's a deeper reason why these things are really important in fundamental physics. If you could go back into the past, or even send a message or signal of some sort back into the past, then you immediately run into paradoxes. You'll know these paradoxes from the movies.
Yeah, like why, if we send it into the past, then why haven't we gotten the thing? And then if we have already gotten the signal, then why would anyone send the signal?
Right, and you could act to change it. So there's a lot of problems involved if you could loop back in time. And even if it's only a subatomic particle that could go back in time, it just seems to play havoc with the nature of reality. And so physicists are really interested in trying to come up with some unified theory in which all the forces of nature are combined together in a mathematical formula. that would show a connection between gravitation and electromagnetism and the nuclear forces and the nature of space and time. And there's a lot of effort being given to such a unification. Now, if it turns out that some branch of physics permits absurdities like these paradoxes of time travel, then it shows you're probably doing something wrong. In other words, we can use the existence of the possibility of time travel to rule out some branches of physics. So it's not entirely a frivolous exercise. And so when you ask, what can you do with this understanding, I think it helps inform the attempts to come up with some sort of grand unified theory of all of physics.
All right. So thank you for being on the show.
Well, it's been a lot of fun, and this is a fun topic. And so I hope I can come on your show again.
There you have it, folks. The show about science is complete. Music on today's episode comes from Epidemic Sound, and our theme song was composed by Jeff Dan and Teresa Brooks. If you want to hear more episodes, make sure to go visit theshowaboutscience.com. Okay, Dad, you can shut the recording off.